Okay, we have here today an interesting integral from the MIT Integration Bee 2006. This is problem 20. We have the integral of cosine 4x plus 1 over cotangent x minus tan x dx. Okay, a couple things I noticed. First of all, having the angle here 4x and then having the angle down here as x, that's kind of a problem, as we usually want the angle to be the same on everything in order to make the trig functions easy to work with. But one thing that's nice here in the denominator is we've got cotangent and tangent. Well, these two are just reciprocals of each other, so it tells me that this might give us some simplification. So I think to start with, let's just look at our denominator and try to simplify this. So for cotangent x minus tan x, I'm just going to want to rewrite this in terms of sines and cosines. So cotangent is going to be cosine over sine, and then tangent is going to be sine over cosine. And then what I think I'll do is get a common denominator here. Let me make some more space. So to get a common denominator, let's multiply by cosine x over cosine x here. And then let's multiply by sine over here to the right. And then when I do this, we're all over the common denominator of just sine x, cosine x. This here is going to give me a cosine squared x. And this here is going to give me a sine squared x. Well, in the denominator here, if we just had a 2 here, this is actually the same thing as sine 2x. Well, we don't want to change it, so let's just divide by 2, so we're actually multiplying by 1 here. So then when I rewrite it, let's take this 2 and bring it into the numerator, so we'll write a 2 here. Now we have an identity for cosine squared x minus sine squared x. This I can actually write as cosine 2x. And then again, for 2 sine x cos x, this is the same thing as sine 2x. So what I want to do is let's just take this and we'll put this back into the integral in the denominator, but let's just kind of see if I can make a little space. So when we do this, we'll still have our cosine 4x plus 1 here. But now for this sine 2x, I'll flip it and bring it into the numerator. So we'll have a sine 2x up here. And then this part, 2 cosine 2x, that's going to be our denominator. But now, like I mentioned in the beginning, we want our angles to be all the same. We still kind of have a problem here because we've got 2x, 2x, and this is 4x. So what I'm going to do then is, let's just focus on that cosine 4x. But instead of cosine 4x, what I can do is write it like 2 times 2x. And the reason for doing it this way is because I want to use the double angle formula for cosine, with the input being 2x. Now we just saw another version of the double angle formula as cosine squared x minus sine squared x. This way we'll do a different, there's three different variations on this formula. We'll do this as 2 cosine squared of this input minus 1. But again, the input on this is just going to be 2x now. So now we're going to have everything in terms of 2x. So now we can take this value here, we can plug it back in for cosine 4x and rewrite it. So let's see what we get when we do that. So plugging this in here, we're going to have 2 cosine squared 2x. Then we're going to have minus 1. We still have a plus 1 here. And then this is multiplied by sine 2x. I'll squeeze in the dx over here, and then we're going to have this 2 cosine 2x. But then, of course, 1 minus 1 here is just 0, so that's going away. And now it's a little confusing to look at, but all this stuff's multiplied together in the numerator, so I can cancel 2 with 2 here. And then I can cancel cosine 2x with one of these here. So then let's just take this to rewrite it to see what we have. So we have here cosine 2x sine 2x dx. But then now, just using the same trick we used before, if I multiply this by 2 again, we have again the double angle formula for sine. So let's multiply by a half out front, just so that we're not changing it. And I know this is out of order, so let's just look at that formula really quick. Our formula for sine of 2x equals 2 sine x cos x. And so the only difference between what we have here and what we have here is just the input, the angle of 2x. So we'll just change all these angles to 2x just to make it clear. And then we have to change this one to 2x as well. But then distributing the 2 over here, this angle here is actually going to be 4x. So what we have over here for this value right here is going to actually be sine of 4x. But now at this point, this is going to become an easy integral. So we'll have our 1/2 out front. This whole thing just becomes sine 4x dx. We'll go ahead and integrate. We have our 1/2 in front. Integrating this is going to be minus cosine 4x. So I'll bring the minus out front. Cosine 4x. We need to bring out the 4 in the denominator, so we'll have this as a 1/4. But then we can just multiply this together and we get our final solution of minus 1/8 cosine 4x plus c, and that's it. Okay, there you have it. Interesting problem from MIT 2006. Thanks everyone for watching. Have a good day.